In this lesson, we'll touch on some concepts around JSON data modeling and document types as they relate to configuring type mappings for full-text search indexing. We'll take a tour of the data model behind the wine search dataset, learning a bit about bucket navigation along the way. Then we'll learn how type identifiers are configured for an index so you can examine their effect in the lab for this unit. JSON documents are a powerful approach to storing application data relative to old-style relational tables. Now, there's nothing new about object orientation. It's a de facto standard in modern software, which is, as you know, largely designed around people, things, and contexts. The problem is that relational databases have never been a great fit for object-oriented data, because objects often cross table boundaries. So the traditional relational focus on disk-first architectures means your big data box needs to seek out different tables somewhere, then marshal all that data into memory, typically on one monolithic box for a big join, just to get it in the shape required for a particular query and the object that needs that data. Yes, object relational mapping frameworks have evolved in response to handle some of the coding labor, but they're complex, and the fundamental mismatch between tabular and object-shaped data leads to complex code that's expensive to maintain over time. Yet, it does remain useful to organize data by its type, because your classes are defined by their type. There's just better and more flexible ways to do this than rigid relational tables. Much of the power behind JSON data modeling is its easy coherence with object-oriented code. Yet that implies that your JSON documents are typed, just like object classes. Well, two patterns have emerged for encoding document type. Document ID prefixes are the first. One big advantage in this approach is that your type information is available without accessing the document itself. There are various conventions for this encoding. In this course, we'll use double colons as a separator, but your mileage may vary. The second common pattern is to embed a type field within the document itself. This approach makes it easy to use type data when filtering queries using nickel. FTS indexes support either approach, though, as we'll see just ahead. So other questions will drive the decisions you make on this point. To learn more about data modeling in JSON, take our free online course, CB105, Intro to Data Modeling in JSON. Now let's jump into Couchbase for a moment and take a look at the wine search documents with an eye on their type and relationships. I'm going to go to the bucket screen and go to my wine search bucket and click on Documents to open all of its documents. Now we have two document types. We have orders and we have products. I actually want to look at my products first, but because of ordering sequence, orders come before products, O comes before P. So I'm going to go to my filter here, and I'm going to filter by the word product to get me to the beginning of the product documents in this bucket. I'll click that, and there we have product at Georgitico 10705. Over here, I'll click Edit to open the document, and notice that we've got fields like province and description and variety and price, and we also have an array of individual orders. We'll get back to those in just a moment, but notice that each order has a customer name as well as a party vibe to describe something about the order in which this particular product was included. If I scroll to the bottom past all the orders, you'll also see a points field as well as an embedded type field. So we're redundantly including type information in two places here. It's both embedded as a type field, it's also included as a prefix. Here I'm looking at the ID in the metadata for this document. Now in production, you'd probably pick one approach and run with it. We're showing both for learning purposes here. I want to get back to my orders because what I want to do is look up the first order that this wine was included in. So I'm going to copy this order ID for the first order in the orders array, BI419, etc. I'll copy that, and then here in the breadcrumb trail, I'll click on Documents to take me back to the Documents screen, and instead of using the filter, I'm going to look up the document ID directly. But we know that our orders begin with an order ; prefix, and then I'll paste that order number after that and look up that specific order, and there we have it. If I scroll down through here, we'll see that, yep, there is my Adjorjitico wine. So there is a relationship between these documents. If you're using nickel queries, you'll find that there are ways to join data together in various patterns. For now, though, just notice that relationship and notice that our product documents and our order documents both have embedded type fields, as well as a variety of long text fields like party vibe and also description in our product documents to play around with for full text search purposes. So let's talk a bit more about type identifiers. You've seen that it's easy to create a full text search index in the last lab if it's for all documents and dynamically indexes all fields in all your documents. It's too easy, maybe, given that you'd only use such a technique if you had constantly changing documents with ever-changing fields. Likely your own data model would be a bit more predictable than that. So full-text search lets you limit any index to one or more document types, and it lets you identify the document type for each index in one of three different ways. You could identify using a type field in your documents, as we just saw a moment ago, or a document ID prefix up to a defined separator, as we just saw a moment ago also. You could also use a regular expression to extract the type information from a more complex document ID. Now, once you've set where the type data is coming from for each document, you add one or potentially more than one type mappings. The default type mapping, as we saw in the last lab, causes all documents in the target bucket to be indexed, regardless of their type. Now, if instead you specify a type mapping value, then only documents that have that value in the location you've specified just above will be included in this index. If you want to include multiple document types in a single index, you could either add more than one type mapping or reach the same functional result using aliasing, which we'll look at later in this course. So what have we learned here? Well, JSON documents easily map to people, things, and contexts, and so on, making Couchbase a great fit for object-oriented code. Relational joins add unnecessary overhead when what you really want is to store and retrieve consistent data structures. There are two prevailing patterns for encoding document type information: either document ID prefixes, which are accessible without the document itself, or embedded type fields, which are usable in nickel filters to select documents by their type from a common bucket. Couchbase full-text search indexing supports both approaches. In the upcoming lab, and much more ahead, we'll see how specific document fields for a given document type are mapped for indexing. In this lab, you'll configure both document type and field mappings and begin to explore basic search behavior with the resulting index. When you're done with that, come on back. We've got a lot more to cover. Stick around.